Okay, we're going to look at in this video at the solutions to GCSE Further Maths 2023, and this is Unit 2, which is the Mechanics unit. First thing I would do is read through the paper, and it tells you, give your answers where appropriate, give your answers to 2 decimal places, and also that G is equal to 10. I think that's pretty standard at GCSE level. The last thing as well tells you that the total mark for this paper is 50. You can see the formulas you're given, and we'll come back to them if and when we need them. Okay, first question says, throughout this question, I and J denote the unit vectors parallel to a set of standard XY axes. A package of mass 4 kilograms is initially at rest at the origin on a smooth horizontal plane. The package is acted upon by the force F, which is 7I minus 8J, causing it to move along a plane. Calculate the acceleration of the package in vector form. So you're using in this question, vector F is equal to M times vector A. So we could rearrange that and say A is equal to vector F divided by your mass M. So in this case, the mass was 4, so dividing by 4 is the same as multiplying by a quarter, so it's a quarter upon your 7I minus 8J. And if you do that, you're going to just get, and I probably just left it as 7 over 4I, and then minus 2J. It says next, after 6 seconds, the package will be at a point P. So it was initially at rest, it told us. The acceleration we've now worked out to be 7 over 4I minus 2J. Your time is equal to 6, and we want to find the displacement at that time. So that's what we're looking for. So you're using vector S is equal to vector U times T plus a half times vector A times T squared. And then just fire everything in. UT is going to be 0 times anything, it's just going to be 0. And then a half times my A, so a half times my A, what was my A? 7 over 4I minus 2J, and the T squared, we'll just write that as 6 squared, and if you did that out, you will get, and it works out as 63 over 2I minus 36J. So we'll just write that in here, 63 over 2I minus 36J. Next thing says, the force F is a resultant of 3 forces A, B, and C. Find the force C in vector form. So that means F basically is equal to A plus B plus C. And the F, and when I did this out first time I made a wee mistake, I put the A in, but it's the F, the force, is equal to 7I minus 8J. And then that equals 4I minus 7J, that was your A. Then minus 2I plus 5J, that was your B, and then plus your C. So just do a wee bit of tidying up. All it is bringing stuff to the other side, that's all. So your 4I minus 2J on the right-hand side is 2I, minus 7I plus 5J is minus 2J, and then you plus your C. And then when that 2I goes across, it becomes minus 2I, leaving you 5I. And when that minus 2J goes across, it becomes plus 2J, leaving you minus 6J is equal to your C. So your answer is 5I minus 6J is what your vector C is. And I think that is question 1 finished. It is indeed. Okay, question 2 said a ball is projected upwards from ground level with an initial speed of 30. So U is equal to 30, and I like to put the arrows upwards. Acceleration then is always going downwards, so that means it's minus 10 upwards. And we want to calculate the time taken for the ball to reach maximum height. U is equal to 0 at maximum height. And then T is what you're trying to find. So you're just going to use V is equal to U plus AT. So that means 0 is equal to 30 minus 10T, or 10T is equal to 30. Wee bit of working out there. T is equal to 3. So 3, and you can see they've got the units in there of seconds, so we don't need to add those in. So 3 seconds. Next part says, calculate the time taken for the ball to fall from its maximum height down to a height of 25 meters above the ground. Okay, we haven't actually found the maximum height. So the easiest way to do this is we're going to look at from t equals 0, we're going to look at the time for this thing to go up, get to whatever its maximum height, I don't know, nor do I care, and then to get to a height of 25 meters. That's what we're really looking for in this question. So we'll see, and we know it is at this maximum bit when t is equal to 3. So we want to find this time here. And then at the end we can just subtract t. So we're finding the time from the very start of the motion. So initially it was projected upwards with a speed of 30. Our A, remember, was minus 10 upwards. Our S, we wanted to be 25 metres upwards. And also we are trying to find our time that happened. So remember, we're trying to find this time here. So again, you'd use S equals UT plus a half AT squared. Fire everything in. 25 then is equal to UT, which is going to be just 30T. And then a half times that A is going to be a half times 10, minus 10, sorry, which is minus 5, and that's times T squared. Bring everything over to one side. Put it equal to 0. And what you can do to make life a wee bit easier here as well is divide through by 5. And you get T squared minus 6T plus 5 is equal to 0. Which factorizes, I'm skipping out the sum and product method, but it factorizes nicely to give you this. Which means T is equal to 1 or T is equal to 5. Now, T equals 1, just to explain on our diagram what that means. At 1 second, when, oops, I should have meant that in green. 1 second here, so when T is equal to 1, it would also be at a height of 25, but that's not the one we're looking at because we know it goes up. And then at 3 seconds it's here, so it's definitely not going to be 1 second when it comes back down. So that's going to be 5 seconds, so get rid of all that. But that's what that all meant. So T equals 5 is what we're looking for. But your answer then, remember, read the question. It says, calculate the time taken for the ball to fall from its maximum height. So we're looking for this wee time here, which is just going to be 5 minus 3, which is going to be 2 seconds. Oops, and again, they've got that seconds written in, so we don't need it, so it's just 2. On to question 3. Question 3 says, a block of mass 5 kilograms is pulled in a straight line along a rough horizontal plane by a force of 30 newtons acting on the block at 37 degrees to horizontal as shown. Calculate the normal reaction between the block and the plane. So we don't need anything else. Let's just mark on a wee diagram here. That would be an R. And you'd also have your 5G going here. We'll mark on, if there's friction, we'll mark that on the next time we come to it. But all you're doing here is resolving vertically. So basically, the forces up equal the forces down. Okay, it is that easy. So going up, you've got R plus, and you want to pull this 30 round to here. You don't have the angle, which means you use sine. So it's 30 sine 37 is equal to 5G. Wee bit of rearranging. R is equal to 5G, which is 10, minus 30 sine 37. And if I've done that correctly, remember it was 2 decimal places, 31.95 newtons. It says the block is moving with a constant velocity. So if something's moving with a constant velocity, that means there's no overall resultant force. If there's an overall resultant force, there would be acceleration. So it means the forces left equal the forces right. Let's just look back at our diagram here. Forces left equal the forces right. So that means I'm going to call this my F. This is my friction. That's what we're trying to find. And then the forces left, just going to be your friction. Your force right is the component of that force in this direction. So it's going to be 30 cos 37. So forces left was my friction, and then 30, is that right? Sorry, 30 cos 37. And that, when I did that out, that worked out to be to 2 decimal places 23.96 newtons, to 2 decimal places 23.96 newtons. There we are. Okay, next question says, the force of 30 newtons is removed and replaced with a force of 45, acting at an angle of 42. So we've changed it up, and the value of the friction is now 15. So we'll mark that on, that is now 15. Okay, we'll just put a wee 15 newtons in there. Calculate the acceleration of the block. So it's accelerating now. Don't need to put in normal reaction, it's not going to have any help to us. So we're going to resolve horizontally, but there's acceleration, so you use F equals ma. So it's not friction, this is the overall resultant force. So to the right, you've got 45 cos 42. Going against that, you've got 15. My mass is 5 times my acceleration. So again, I do as little as I can in the way of working out. By that I mean I don't put much into my calculator early on, so I'm letting the calculator do all the work. Just rearrange, brought that 5 across, so you'll have 45 cos 42 minus 15, all divided by 5, and then my A works out to be 3.69, and that's going to be meters per second squared, and that's the 2 decimal places. Okay, question 4 says, 2 blocks P and Q of masses m kilograms and 9 kilograms respectively are connected by a light inextensible string passing over a smooth pulley. Block P is held at rest on a rough horizontal table, and block Q hangs vertically above the ground as shown in the diagram. The blocks are released from rest, and the force due to friction is 51.6. It says mark on diagram above all the forces acting on a block. So first of all, let's mark on the friction. That's 51.6 newtons. You're going to have your mass, your weight, of this mg. You're also going to have a normal reaction here. You're also going to have the weight of this thing, which is going to be 9g newtons. And then this is where you're going to have your friction acting here. There's also going to be a friction acting here. As a tension acting there. Tension going back here and a tension going here. So that's what you've got. And it says, that's it done. That's all we have. Yep. It says after 0.75 seconds, Q has moved down. So it must have moved. So there must have been acceleration. So your A is going this way, and also it's going this way. So put it on both, please. Okay, next one says, this part says calculate the acceleration of the block. So it says after 0.75 seconds, Q has moved down this amount, and P hasn't reached the pulley. Okay, so after that time, it has moved down 0.675, and initially it must have been at rest. So there's where we get everything we need. So you're going to use, again, the most common of our SUVAT equations to use, S equals UT plus half AT squared. I think it's probably the third time we've used it already. 0.675 is equal to 0, plus, I'll just write my half as 0.5, times my A, which I'm trying to find, times my 0.75 squared. And then that's going to be 0.675 is equal to, when I did that out in my calculator, I got 9 over 32 times A. And then that's 0.675 divided by 9 over 32 is equal to your A, which means your A works out to be, for me it worked out to be 2.4 meters per second squared. Okay. Next question says, calculate the tension in the string. Apologies. So calculate the tension in the string. So to get the tension in the string, I'm going to look at this one. Right, I could have looked at either of these, but I can't look at this one and consider F equals ma because I don't know the mass. So there'd be two unknowns. There'd be the tension, which is unknown, and also the mass. So that's why we can't look at that one. So, apologies. So we're going to have to look at the Q. So that's really what we've got going on. You've a force of 9g going down. Going against that, you've got t, and you've got a mass of 9, and you know the acceleration now as well. Okay, so that's what we're going to look at. So again, we've got 9g going down. You've got your t going up, and you've got your mass is 9, and you know your acceleration. So that's, I'll just very quickly draw that again. Say, first of all, say at the 9 kilograms. So you had your T going up. It was 9 kilograms. You had 9G going down. It was accelerating downwards, and we worked that out as 2.4, was it? 2.4. Yep, 2.4. 2.4 meters per second squared. So we're just going to resolve downwards using F equals ma. So my force down is 9G. Going against that is T. And then that is equal to my mass, which is 9 times 2.4. Wee bit of rearranging, that's 9 times 10, was my 9g. Then minus 9 times 2.4 equals your t. So your t works out to be 68.4 newtons, so 68.4. The last thing says calculate the mass of m. So we're going to do the same thing. We're going to look at m kilograms. I'll go back to my diagram here, bear with me. So if we go back to this diagram, I'll get rid of that circle, and we're now zooming in on this. So these are the forces which are acting. Forget about vertically, we don't need to find the R. Oh, we do need to find the R. Apologies, that's exactly what we need to do. No, it's not. That's nonsense. We don't need to find the R at all. We need to find the go horizontally. We now know the tension. And we also know the resistive force. We know the acceleration. We don't know the M. So I'll just draw that diagram out again. The horizontal bit, the bit that we are concerned with. So we've got your M kilograms, and pulling it forward is tension. Going against it, we were told was 51.6. The tension as well. Okay, so you've got your tension, which we know. The tension was 68.4. And then you've got your acceleration as well, which was 2.4. So we are good to go. We're going to resolve horizontally. We're going to use F equals ma. So the pulling force is 68.4. Going against it is 51.6. My mass is m, that's what we're trying to find, times my acceleration, which is 2.4. So that means 68.4 minus 51.6, all divided by 2.4, will be equal to m. And when I worked that out, I got m was equal to 7. So a pretty nice answer. And 7. They haven't any units. I would just put in the 7 kilograms. Okay, next question. 2 more to go, I think, just. Right, this is a moment's question. It says, uniform rod AB rests on a pivot. So it's pivoted on this point at point C. The rod is of length 6, which means mark on, and it's a uniform rod, so mark on. That's 3 meters from the NB to the center, and the weight is 3.5 G newtons. It also tells you a mass of 4.5, so this is this ball today, is attached today, so 4.5 G newtons. 2 kilograms is here, so that's 2 G newtons, and the diagram as shown. Okay, and you also need to find, it says the rod remains, mark on the diagram, all the forces done, that was part 1. Calculate the reaction at the pivot C. So this is just your R. So this one is really, really easy. You don't have any moments to take here, you're just resolving vertically, and it really is just your forces up equal your forces down. So R is the only force up, so it's equal to 4.5 G plus 3.5 G plus 2G, which means R is equal to, fire that all into your calculator, 100 newtons. For the next bit, it says calculate the value of X. So I'm going to take moments about A, and I'm going to put clockwise equal to the anti-clockwise. Let me just draw that out again. It just saves me going back and forward. So there I had 4.5 G newtons. I had my pivot at C. There was my point A. That was X meters away. That was my R, which we just worked out to be 100 newtons. This 3.5 G, it was 3 meters away. And then this whole thing is 6 meters away. That was at C, or B, sorry, that was 2 G newtons. Okay, so we're going to take moments about A, and we're going to do clockwise equals anti-clockwise. So this is something people really struggle with then, doing this. So the moment is a force times a perpendicular distance. So from A, clockwise, this force here would be going clockwise. This force here would also be going clockwise. So I'll just put those in first. Let me get rid of those arrows. So the first one there was going to be, it was 3.5 G, and it was 3 meters away. And then the other one was 2 G, and it was 6 meters away. Okay, my anti-clockwise then. Only one anti-clockwise, it's this one, going in this direction. So that's going to be 100 times X. So equals 100X. So again, I just worked those out, I think. 3.5 G times 3 was 105. This one, 2G times 6 was 120, and that equals 100X, which means 225 is equal to 100X. And a wee bit of working out then, your X is equal to 225 over 100. Your X works out nicely to be 2.25 meters. Okay, last question, which not too many people were happy about. It says, a car is travelling at a constant velocity of 60 meters per second. It passes a stationary motorbike, and 10 seconds later, the rider of the motorbike gives chase. The motorbike accelerates uniformly for 15 seconds until it reaches a velocity of 24. It continues at this velocity until it catches up with the car. So I'm going to do here 10 seconds, mark on 10 seconds, and then 25 seconds, because it accelerates up to a speed of 24. This is just a sketch, so it doesn't really matter, but it does that in 15 seconds. It then maintains that speed until it catches up, and I'm going to say it catches up at time t. Okay, so, and that's my motorbike. I'll just write bike here for that. Hence or otherwise, after the motorbike starts moving, calculate the time taken for the motorbike to catch up with the car. Right, when the motorbike catches up with the car, that would mean that the distance the car has travelled, which is represented by that rectangle, easy peasy, just find an area for rectangle. So the distance travelled by the car will be the same as the distance travelled by the motorbike. So those two distances are going to be the same. Okay, so that's what we need to find. So the car one is going to be easy. The distance for the car is just going to be 16 times t. I'm just going to do this here, just so I can see it. You would do it obviously in an exam in the correct place. But for the car, the distance is equal to just 16 times t. And for the motorbike, we have a wee bit more work to do. So for the motorbike, this is a trapezium. Now people don't like using the trapezium, but I would use the trapezium. It does make it a lot easier. So that's t minus 25. This length, this parallel side, is t minus 10. And the perpendicular distance between them is 24. So that means distance of a trapezium, it's a half a plus b. The area of a trapezium, I should say, half a plus b times h, where a and b are your parallel sides. So it's a half of t minus 25 plus t minus 10 times the perpendicular distance between them, which is 24. Right, sort out the half times the 24 is 12. T plus t is 2t. Minus 25 minus 10 is minus 35. And then if you multiply it out, you're going to get 24t minus, and that's going to be 350 plus another 70 is going to be 400 minus 420. That's right. And then we're going to put those two things equal. So we just put those equal. Go on down to this next page now to do that. Just put that equal. What do we have? 16t. Put 16t equal to 24t minus 420. Zoom in on that now. So we've got that. So 16t is equal to 24t minus 420. That was putting those things equal. So 420 then is equal to 24t minus 16t. 420 is equal to 8t. 420 divided by 8 is equal to t. So your t is equal to 52.5 seconds. Okay, now the question says, hence or otherwise, after the motorbike starts moving, calculate the time taken for the motorbike. So it's after it starts moving. So it's only the motorbike hasn't been moving for t. The car's been moving for t. The motorbike, you can see here, has been moving for, it only starts here at 10 seconds less. So your answer is going to be i.e. motorbike has been traveling for 42.5 seconds. So 42.5. Last thing says the distance which the motorbike has travelled in this time. So the formula that the motorbike was using for distance was this one, remember? Distance for the motorbike was equal to this thing. So for the motorbike, distance was equal to 24t minus 420. So we're just going to say for this one, sub r time t, which was this time here, very importantly, sub t equals 52.5 into whatever I've just said. S is equal to, sorry, we hadn't written S, we'd said distance. Distance is equal to 24 times t minus 420, so it becomes 24 times 52.5 5 minus 420, which works out to be 840 metres. Okay, and I think that's us. No, it is not. Apologies, it's not us done at all. Okay, what happens next is the moment the motorbike reaches its car, the motorbike decelerates at 1.5 metres per second until it comes to rest. The car continues travelling at 16 metres per second. So after the motorbike comes to rest, which vehicle is further ahead and by how far? So we're going to just look at the bike first of all. The motorbike, it was going at 24 metres per second. It then decelerates at decelerates at 1.6 metres per second, which means it's acceleration. Acceleration is minus 1.6. Comes to rest means your v equals 0. And we want to find two things. We want to find the distance that he goes and also the time it takes him, because then we'll need to use that for the car as well. So we'll find our s first by using v squared equals u squared plus 2as. So we've got that, which means 0 is equal to 24 squared, and that's going to be plus 2 times my a, which is minus 1.6 times my s. Bring that across, and a wee bit of rearranging. What did I get? I think I worked that out. Sorry, I did work that out. That's going to be positive 3.2 times s is equal to 576, which means a wee bit of working out then. Oops, my s is 576 divided by 3.2, which gave me my s was 180 metres. So we know the bike in whatever time has gone 180 metres. Okay, so we're still on the bike, and we're going to look at find the time. So we're going to use v is equal to u plus at. Okay, so v is equal to u plus at, so it's 24 minus 1.6t. 1.6t is equal to 24. T then is equal to 24 divided by 1.6, which means t works out to be 15 seconds. So the bike, what we've worked out so far, the bike has gone 180 metres and done that in 15 seconds. So now for the car, he had continued going at the same speed, which was 16 metres per second, and he's going for 15 seconds. We want to see who goes further in that 15 seconds. So he goes 16 times 15, which is 240 metres. So that means who has gone further? The car has definitely gone further. And by how much? 240 minus 180. He has gone further by 60 metres. And that is the end of the exam. At the end of the exam, you go through and check you haven't made any silly mistakes. I made a couple when I was marking through that. You'll be surprised to hear, but just check your work as you go.